What happens when AI correctly diagnoses a dying patient in its internal code but tells a doctor just wait and monitor? The Sinai Chatgpt study reveals a terrifying reality about clinical AI and how we must fix it. Welcome back to the channel. My name is Dr. G, and today we'll be discussing a phenomenon that should keep every medical tech investor, hospital executive, and a physician awake at night. I want you to imagine this scenario. An AI as a clinical agent is monitoring a patient, your patient in the ICU. The patient's vitals are dropping, the oxygen saturation is plummeting, the AI processes the data, and in its internal data, of course, and internal reasoning, correctly identifies that the patient is an acute respiratory failure. It knows exactly what is happening and the pathophysiology behind it. But when it generates its final recommendation to the clinical team, instead of calling a code or suggesting an immediate intubation, it says, wait and monitor. A lot of questions is going in your head. Why did it do this? How can artificial intelligence know the exact right medical answer, but output the exact wrong clinical actions? This is exactly what was uncovered in a recent discussion surrounding the Mount Sinai ChatGPT health study, as brilliantly broken down by, of course, other people who has reviewed this case, including Ned B. Jones. We're going to be witnessing a terrifying reality in the deployment of large language models in healthcare. The total disconnect between an AI's reasoning trace and its final output. All right, sit with me and let's do this together. Today, we're going to dive deep into why medical agents fail in production. We will unpack the four critical failure modes in clinical AI, from the inverted U of performance to the hijacking of clinical judgment by social context. And more importantly, we will discuss the four layers of architecture required to build evaluations that actually catch these fatal errors before they reach the patient. If you're building, buying, or using AI in medicine, I'm building Docerian. Docerian is an IP provided to help people do intake, do analysis, case review, differential diagnosis, patient management, basically designed for Africa. You can go check that. The link is going to be in the description. You can afford to miss this if you are in healthcare. Let's get into this. So first and foremost, to understand why an AI will accurately diagnose respiratory failure but recommend clinical inaction, we must fundamentally understand how modern LLMs are trained. So models like ChatGPT, Claude, or Gemini undergo a process called reinforcement learning from human feedback, or RLFH, right? This training aligns the model to be polite, to be helpful, and above all, to be safe. However, in the context of high-stake medicine, safe to an AI means avoiding definitive medical advice at all costs. All right, so it also highlights a critical failure mode. The reasoning trace contradicts the output. So when you ask an LLM to, to do a complex or you ask him a complex clinical question, it will generate an internal chain of thought. It looks at the labs, the imaging, reports, the vitals, and correctly deduces the pathophysiology. But then the safety guardrails kicks in. The model realizes, wait, I'm an AI. I shouldn't be diagnosing respiratory failure. Let me hedge my bets, right? The final output becomes watered down, dangerously conservative recommendations like consider continuing to monitor a patient and consult a physician for someone in respiratory distress, right? So in a high-stake medical environment, hedging is harmful. That's a fact. But when a patient is crashing, wait and monitor is not a safe answer. It is a fatal one. AI didn't know that. This proves that smarter models do not automatically equate to safer models. An AI can be a brilliant diagnostician internally, but it's going to be a terrible liability inducing clinician externally. I'm going to break this down to four specific failure modes that standard AI benchmark completely miss. But the factorial stress testing at Mount Sinai, of course, revealed these failure issues we're going to talk about today. First is what I'm going to call, or what is popularly called, the inverted U. In human medicine, we expect that if a case is extremely obvious, like a patient with a massive trauma, any clinician knows what to do. If it's extremely subtle, they might miss it. AI agents, however, failed at both extremes. They perform well on average, middle of the road clinical vigilance, because that is, of course, the bulk of their training data is on. But throw them a curveball, an extremely obscure rare disease, or paradoxically a massively obvious trauma, where the system expects a trick question. And of course, AI performance just plummets, right? It overthinks the obvious and hallucinates on the obscure. The second failure seen in that study is what we've just discussed, is the reasoning trace contradicting the output. The inner monologue gets the diagnosis right, correct, because it's talking to itself, right? But however, the outer dialogue gets the management wrong due to over-alignment and safety guardrails prioritizing refusal over intervention. All right, so the third failure mode we saw in these AI models is them terrifying for medical equity. So let's say a social contest hijacks their agent a lot of times. All right, you feed an AI agent a clinical prompt, but add a line saying the patient is a VIP, a wealthy executive, or conversely, unhoused or uninsured. The AI clinical recommendation changes immediately. The vibes of the prompt hijack the clinical logic. AI might recommend unnecessary expensive imaging for the VIP while suggesting immediate discharge for the unhoused patient despite identical clinical presentation. This is massive ethical and liability risk that threatens the scale of systemic healthcare biases. All right, so at the fourth failure mode that is in this study is the fact that the guide rails that fire on vibes, not real risk. Sometimes simply mentioning words like suicide, abuse, narcotics will trigger the AI's refusal mechanism. Right? A physician might be trying to ask the AI to summarize a previous psychiatric evaluation to expedite patient transfer, and AI output refuses, stating it cannot discuss self-harm. All right? The guide rail fires based on keywords rather than understanding the clinical utility of the physician's request. So, how did researchers catch all these flaws, right? They didn't use the standard benchmarks like having an AI take a USMLE, passing. The truth is that passing a multiple choice medical board exam does not prove an AI can safely manage a dynamic patient. Instead, they use factorial design, same with humans, of course. So, factorial designs involves taking a baseline clinical scenario and systematically altering variables one by one, right? You take a case of pneumonia and change the patient's age. Then you change their gender, then their socioeconomic status, then the severity of their oxygen saturation. By running thousands of permutations of the exact same clinical call, you expose the fragile edges of the AI. Right, so you discover that the AI treats a 65-year-old male with pneumonia perfectly, but recommends lethal discharge for an 85-year-old female with the same exact vitals. This factorial stress testing revealed the hidden biases and failures models or failures this mode kind of that standard evaluation completely miss when you do it using standard evaluations. So how do we fix this? Now, if you're a hospital CIO, an investor, or a health tech founder like me, you cannot just slap a raw LLM API into an electronic health record and hope for the best, right? You must implement a four-layer architecture to keep agents honest in production. And I'm going to talk about the all four-layer. Layer one is a progressive autonomy, not full autonomy. All right, AI in healthcare must start as human in the loop, co-pilot. All right, the AI draft the clinical notes, the doctor reviews it, the AI suggests differential diagnosis, the doctor signs off, we must earn the right to move human on the loop, and then eventually for only the lowest risk administrative tax, human out of the loop. All right, so layer two is deterministic validation rules. We cannot rely on probabilistic language models for hard medical facts. No, we must build deterministic, hard-coded rules around the AI. For example, if the AI agent drafts the plan to discharge a patient, but the heart rate of this patient is 130 and the oxygen is at 8%, a hard-coded deterministic rule must block that output. Right? So the AI doesn't get to debate. No, the deterministic rule overrides the probabilistic model to prevent patient harm. Basically, like protocols you offer us as doctors, the AI will need medical protocols that guides its actions and also checkmate its output. Layer 3 is building a continuous evaluation flywheel. Evaluation is not a one-time asset you pass before deployment. It is a continuous pipeline. Every time the AI agent makes a mistake in the real world, that specific scenario must be logged, anonymized, and added to the automated evaluation library. Now, the next time you update the model or switch providers, the new agent must pass that historical test to ensure regressions don't occur. And the final layer 4, I'm thinking will make sense, is the factorial stress testing in production. Just like Sinai did in their studies, hospitals and developers must actively run thousands of synthetic perturbed patient testing, right? Using patient profiles through their life agents. You have to actively try to break it. You must try to do that in a sandbox environment to catch all the edge cases before a real patient is harmed. And finally, we're going to talk about the future, specifically regarding AI liability and insurance. Now, the truth is that operators who ignore this failure today, right, failure modes today, will face them tomorrow. Whether through the patient's harm, regulatory crackdown by the FDA, or whatever regulation you have in your country, or the sheer inability to secure malpractice insurance for your own very software, right? So in the future, I'm seeing a space of cyber liability and medical practice insurance where they will begin to struggle, not on the right people's AI healthcare agents, unless the developer can prove that they have implemented factorial stress testing and deterministic guide rails. So black box LLMs are uninsurable. Transparent, rigidly evaluated agentic workflows are the only pathway forward. And in conclusion, I want to say that the Mount Sinai ChatGPT Health study deserves further look because it kind of serves as a profound wake-up call for all of us and for the entire medtech industry. We are, how do I put it? We're overwhelmed with the brilliance of AI reasoning, but we are severely neglecting the safety of its output. By understanding the disconnection between the chain of thought and the final action, and by implementing the strict 4-layer evaluation architectures, we can build medical AI that doesn't just sound smart and actually saves lives in the long run, right? So thank you for joining me on this deep dive. I'm running Docarian. It's docarian.com. It's an API to support, to connect to your EHR and do a lot of things for you. So please subscribe to this channel, share this video with someone who you think needs to see this, and let me know your thoughts on AI guardrails in the comments below. And until next time, keep innovating safely. Bye.